Hello, everybody. Welcome to another discussion on dynamics. Today we have, I think, quite a lot of things to do. So without further ado, let's dive straight into our discussion, okay? Plan for today, I'm going to very brief lecture review, okay? It will take like 30 seconds, okay? And today we will start a new topic, as you can see, kinetics of particles, yeah? So please think right now about everything we did so far. Have we ever talked about mass of particle before? No. We cared only about geometry of the problem, yeah? Today, for the first time, we will see things that have mass in our problems, yeah? Think of that, okay? That's a big difference. And we are going to do two examples. Example number one and example number two. Example number two, there is a part of that example that is a monster, okay? So I want to get there today for sure, okay? Before we start our discussion, I think that students like to see course content, okay? So this is our timeline, yeah? These are exactly 8 topics we're gonna cover this semester, okay? And today we are here. We are at kinetics. As you can see, that means that we can cross out kinematics. We are done with kinematics of particles. Then we will do, so first part of the semester is kinematics, kinetics, work, energy, momentum of particles, yep. And then second part of the semester is these are exactly the same topics, but for rigid bodies, okay? We will see the diagram a lot this semester. Yeah, I think that students like to keep track of the things. Yeah, you like to see where we are at the moment. Okay, questions? Brief lecture review then, okay? So yesterday, Professor Sunny talked about kinetics of particles, basically, yes? So for the first time, you guys saw, and we saw F equals to ma. What does it mean? That means that if we have a particle, and there is a force acting on our particle, yeah? Force F. That means that our particle will start accelerating, okay? And F is parallel to A, okay? If force F acts on our particle that has mass, our particle will start accelerating in the same direction. That's all. That's what I wanted to say. We are going to use that information today to solve these two problems, okay? And FBD stands for free body diagram. Free body diagram. And KD stands for kinetic diagram. Okay, on the free body diagram, we show all the forces acting on our particle. On kinetic diagram, we show accelerations that our particle will experience, okay? So make sure that you include it in every solution in this topic, okay? In kinetics. This is required, yeah. And of course, this is so basically F equals to ma, yeah? Forces on the left-hand side, forces on FBD, accelerations on KD. Questions? It was more than 30 seconds, sorry. Yeah, my review was more than 30 seconds. But questions? If not, example number 1. I hope font size is fine for the people in the last row, yes? Great. Okay, please familiarize yourself with the problem statement before we start our solution. Yeah. Okay, so what do we have in here? Aha, they told us to they told us untrue information. I mean, that was like too strong statement. Sorry, guys. So basically, they told us that rest length of that spring is that we should assume that the rest length is right after putting the scale on the spring. This is not true. Let me show you another board, okay? This is the rest length, yeah? Without the thing on it, yeah? But once you put a platform, yeah, on our spring, we have initial pre-compression, yeah? However, they told us to neglect that initial pre-compression. They told us forget about it, yeah? And assume that this is rest length. Just assume, okay? Assume that this is rest length, yeah? So they told us to do it, we're gonna do it, okay? I just wanted to clarify that point. Okay, so this is our rest length. Yep. And what? And they told us to place a mesh on that platform, and if we place a mesh on that platform, our scale will go downwards. Yeah. And they told us to find maximum reading of that scale plus maximum speed experienced by the platform plus mesh placed on it. Okay? Any questions to the problem statement? Let's start solution then. So you're going to be super surprised, but we are going to start with free body diagram. Okay? We're going to start with free body diagram. Free body diagram. And kinetic diagram. Okay, but just to save some ink, I'm going to write from now on FBD and KD, okay? And again, in here we're gonna show all the forces, and in here we are going to show all the accelerations, okay? On these two diagrams. Okay, so let me draw our particle that has mass m. It has mass m. Okay, I'm going to draw exactly the same drawing on the right-hand side. Exactly the same thing, the same rectangle. Okay, so what forces act on our particle? First of all, we have mg, gravity. And what is the next force acting on our particle? Spring, great. So it will be kx, okay? Because spring is linear. They told us that spring is linear, that's why it's kx. Okay, and maybe let's assume that this direction is positive, okay? So this will be ma. All right, any other forces act on our thing? No, second step. Equation of motion. Or just to save some ink, I will write EOM, okay? EOM. So let us sum the forces, yeah? Sum the forces in this direction, and this is positive direction, right? So I believe that mg acts in a positive direction, and we have to subtract ky. Okay, I wrote it there kx, okay? I will replace that x with y, okay? I hope you guys won't hate me. Okay, so these are forces acting on our structure. And we said that our thing accelerates, so we have ma. All right, that's it. We just expressed these two drawings in this mathematical form. Do you see? There is a connection between FBD and KD and our equation of motion. Okay? So let's solve for acceleration. A is equal to G minus Km. Why? Okay, and I would like to integrate. And you guys can clearly see that our acceleration is a function of position. Yeah? So I think that this guy is a little bit useless for us. Yeah? We must modify it to the other form. Okay? So I'm just going to do this thing. So this is dv dt dy dy. Okay, so that would be v dv dy. Okay. So that would be v dv dy equal to g minus km y. Everything with v on one side, everything with y on the other side. V dv is equal to g minus kmy dy. And let's integrate. Okay, so I believe that system starts from rest. Yeah? Yeah, exactly. System starts from rest. So we will start with velocity 0 at deflection 0, and we will end up with some velocity v at some deflection y. Okay, so these integrals you, I don't know, I'm gonna say my grandfather's joke. Yeah, you eat on breakfast or something. I don't know. No, okay, don't laugh again. Okay, so we have gy in here minus km, and my grandfather was a good guy, by the way. Yeah, just to clarify. Y squared. Great. So we have our expression. We have our equation of motion, different form of our equation of motion. Yeah, before we had equation of motion on the level of velocities, accelerations. Now we have our equation of motion on the level of velocities. Yeah, and I think that we are very close to solve that problem because they ask us in part A for maximum reading of that scale. So I believe that we should find where the thing has maximum deflection. Yeah, if we have maximum deflection of the spring, then there will be maximum reading. Okay, so what do you think, guys? What is requirement for maximum deflection? Perfect. Requirement for max deflection. Question mark, and the answer is velocity is equal to 0. Thank you. So 0 is equal to g y max minus 1/2 km y max squared. I believe that those y's max can be cancelled, yeah? And we'll end up with our y max equal to what? Two mg divided by k. Okay, but they ask us for maximum reading, yeah? So max reading of the scale is f max. Spring is linear, yeah? You remember k y max. So let's plug that value we just obtained in here, and we will have k times 2mg divided by k, and those k can cancel out. Yeah. So our f max is equal to 2mg. Interesting, isn't it? It's twice as much as the body's weight. Yeah. So every time you step on the scale, it actually thinks that you're twice heavier than you actually are. But it shows the correct. Hopefully, it shows the correct weight. Yeah. Oh, I forgot about that. Okay, any questions? This is answer part A. Yeah. Am I speaking too fast? Or is it fine, guys? Is it okay? Okay, you remember of the, I am recording, remember of the videos. Yeah? Even if I speak too fast, I have a reason for that, okay? You can always watch the video. And remember to like, subscribe, and leave a comment. Okay, this is end of part A. We still have part B to do, yeah? Part B. What was part B? I already forgot. I would like to scroll up the board, okay? Find the maximum speed of mass m. Okay, maximum speed right now. Max speed. Oh. Okay, so I solved it yesterday by taking this expression. I took this expression. And I wanna find max v. I wanna find max v. So maybe you guys can give me a hint. How to find max v? In other words, do you remember calculus? Oh, yeah, sorry. Yes, exactly. Derivative of anything. Yeah, we can take derivative of time, derivative of position. Yeah, but in here we have velocity expressed as a function of position. Yeah. Yes, exactly. So Kyle just remembered what happened on calculus. Yeah, do you remember every time they ask you to find maximum value of a function, what did you do? Derivative over the variable. Yes. Yeah. So this is what Kyle said. Yeah. Let's take. So this is exactly what he said. D over dy. Yeah, because our velocity is basically function of y. Oh, shoot. Okay, so I think that the left-hand side will be v dv dy, and this is equal to g minus km y. Yeah, and you, Kyle, said that our derivative has to be 0. Yeah, if we want to have velocity max, this must be 0. Yes, for v equals to v max. Okay, so we can find y for v max, yeah? So that would be mg divided by k, yeah? Maybe let me show you how I got here. So I just got 0 is equal to g minus km y, but for v max. Okay, so now we know at which deflection our velocity is maximum. So Kyle, what do you want me to do right now? Because this is not what they ask us for, yeah? Perfect. Plug it here, exactly. And we will obtain that our V max is equal to square root of 2g y for V max minus km y of V max squared, yeah, square root of that. Okay, if you plug in values, guys, this just plug in our expressions. So plug in this in here, and here. Okay, and you will end up with V max equal to g and square root of m divided by k. This is our answer, part B. Questions? No questions? So that means that everything is clear or nothing is clear. Is everything clear? Yeah. Okay. So this is how to. I just wanted to illustrate how to use FBD and KD, how to create equation of motion, and then a little bit of review of mathematics, yeah, of calculus. Yeah. Just that. FBD, KD, EOM, and calculus. Okay, guys. So what do you think? Do you wanna go to example number 2, or are you still writing? Example 2, yes. Let's do it. Yeah. Can I have the attendance list? Yeah. Familiarize yourself with the problem statement. Oh, not this one. Nice. Please familiarize yourself with the problem statement before we start our solution. Okay. John, are you here? John Brooks? No. Okay. All right. I hope you guys are reading those statements before coming here, yes? It is beneficial for you, yeah. All right, guys, so what do we have in here? Aha, we have two bodies this time, yeah? We have two masses, yeah? We have this trolley, I believe. Yeah, this trolley of mass little m, and this crate. We are just going to model it as a particle in this problem, okay? In general, it's not a particle, but we are just gonna model in this problem. It's fine to model it as particle. It has mass capital M. Okay, we are on Earth, so it's G. That trolley has green acceleration, yeah, A star, I called it, and it is 1.5 feet per second square. We know the incline, 25 degrees. Okay, we know masses. Actually, we know how much our bodies weight. So we have 40 and 50 pounds. And we know, oh, this is important. System initially at rest. We will use, this is very important information. We will use it later in this problem. And they ask us to find relative acceleration. So they ask us to find acceleration. So when you sit on A, if you are here, that blue creature there, if we are here and if we sit and travel with crate, and when we look at the, if we travel with trolley, and when we look at the crate, they ask us what will we see? What acceleration will we see? And they also ask us to find this tension in the cable that pulls the trolley up. Okay, this red T. They ask us to find this red T. Questions to the problem statement? So I'm not going to surprise you guys that I'm going to start with FBD and KD, okay? And since we have two masses, we are going to draw it twice, okay? So let's write that. We have two masses, we should draw two FBDs. We have two masses. That implies we will draw two FBDs. But first things first, okay? Let's focus now on the crate. Okay? Let's focus on crate. So we will have FBD for crate. And also KD. So this is our crate. This little rectangle. I'm going to draw exactly the same rectangle here. So I think that only if I scroll up the board, only two things act on the crate. This guy, this thing. I believe it's gravity and tension in the cable. Do you agree? There is no other things, yeah? So we have mg, and that would be big mg, yeah? Because mass of crate is capital M. And also, let's call this one, I don't know, the tension in the cable is F. Okay, and let's assume that our body accelerates this way, MAY. Or, and also it can accelerate this way, yeah? But we already know what that value will be, MAX. You guys can clearly tell me that AX will be 0. Why? Because there are no forces acting on this direction. Do you see? Only forces act only along the vertical direction. That's why MAX is 0. Okay, second part, EOM. So, okay, but let's do it quickly. I don't even have it in my notes, I neglected the X direction. So this is positive direction, yes? So we have 0 in here, and this is equal to MAX. And that clearly implies that AX has to be 0. That's also important information for us, because we know that our crate is going to move upwards. Yeah, it's not going to move to the side. Okay, and now sum of forces in the Y direction, and I believe we decided to have this direction as positive, and we have F minus mg, and this is equal to MAY. Great. I like to keep the equality sign aligned, one below another. Okay, so we have one equation, yes? So we have this equation. This is our equation. Let's see. So we have one equation. And how many unknowns? I'm wondering. Oh. So I believe that we do not know the tension in the cable. Yep. And we don't know the acceleration. Yes. Is your name Sanam? Yeah. Am I doing a better job than last time with writing at the center of the board? Yeah. I hope, yeah. Sometimes I forget about it, sorry. Yeah. I'm worried a little bit. Yeah. So we have one equation and two unknowns. Solvable or not? Not solvable. We need more information, yes? However, and so we are gonna draw the other FBD. But before moving to another FBD, keep in mind that we know that our guy has only this direction. Acceleration has only this direction, okay? We have one more information, that our A crate or let's call it AB, okay, body B. AB is in this direction. AY, J. Okay, it has no X component. This is also important information. Just keep that in mind. Okay, we know that the horizontal component of acceleration is 0. Okay, now we need more equations, yeah? So how about doing FBD, this time for trolley, and KD as well. Okay, so I'm going to express that trolley as such rectangle, okay? And the same in here. So what forces act on our trolley, guys? If you look at that picture. What forces I should draw in here? I will start because I like easy things, gravity, mg, and this time small m, okay? mg. Any other force? Question mark? Tension in the cable, perfect. We have two cables, yeah? So you meant this tension? Yeah. And also there's another cable, yeah? And I think that it would be F, yeah? This F is exactly the same as this F. Yeah, they just point in the opposite directions, okay? This is the same force in the same cable. Okay, is there any other force acting on our trolley? Normal force. In which direction? Perfect. I will call it N, okay? Exactly. There should be N that supports our trolley. Yeah. All right. And I would like to express that motion in this thing, in this coordinate system. We'll have MAP in PQ, okay? P and Q. P and Q. That is aligned with the track. And in here we have also MAQ. Okay, guys, by the way, what is the value of AQ? And why? We know that's good beginning of the sentence. Yeah, along the track, yeah. Our body can move only here, along this direction, yes. And that implies AQ. AQ being 0. Thank you so much. And I don't know your name, actually. Scott, okay. Thank you, Scott. Great. Okay, we are done with our FBD and KD. So next step is EOM again. Equations of motion. So let me write sum of forces among P direction. And we decided that P positive is this direction, okay? Aha, but before doing that, so we already see that we have T acting along this direction, yes? But I think we guys need to do some projections, yeah? So I need to project mg and f on this direction, yeah? And theta is here. So we need these values. We need this component of mg and this component of mg. So if theta is here, I bet that theta is here. So this one will be mg cosine or sine of theta. Cosine, yes. So this one has no other choice. This will be mg sine theta. Mg sine theta. Okay, let me switch the color for maybe orange. And this orange thing will be projection of f on the p direction, and this orange thing will be projection of f on the q direction. So it's analogical, yes? So this one will be f cosine theta, and this one will be f sine theta. Great. Now we are ready to write equation of motion. So you guys told me that this is t, and I believe that we have minus mg sine theta minus f sine theta. And this is equal to our acceleration, MAP. And now forces in the q direction. Forces in the q direction, and I believe that positive direction was in this way, yeah, in this direction. So in there we have n, blue vector, and we have two negative stuff here, mg cosine theta and minus f cosine theta. This is equal to MAQ. But Scott told us a very important thing, that this is 0. So we can just write 0 in here, that this is equal to 0. And by the way, AP is A star. Do you remember from the beginning? That the green vector here, AP is exactly A star. And we know that value. So it's important. So it's important because it simplifies the problem. Yeah. So this guy is A star, known A star. So I'm gonna write it here, MA star. Okay. What do you think about that, guys? Are we on the same page so far? Yeah. Okay. We just draw FBD, KD, KD, and EOM, and we write down EOM for those two masses. Okay. Can we continue? Or questions? Yeah. I hope you like the style of my discussions, because I just try to do like some chunk of the material, and then you have time for questions. Yes. You have time for questions, then we do more, and then again questions. Yeah, I think that this is like very ordered. Yeah, I hope you like it. And if you don't like it, actually, at the same time, there is different discussion with different TA. So if you don't like me, you can go to another guy, or I don't know who is that person. Yeah, actually. So yeah, you can always switch. Yeah. Okay, so yesterday I solved that problem, and I noticed that we don't need this expression. This equation, it does not contribute anything to our solution, okay? Sometimes that happens, yeah? This equation does not contribute anything to our solution. Does not contribute anything to our solution. Okay. But the first guy does. So let me sum up what we have right now. I believe that we started with one equation and one unknown. Yeah, this guy. Sorry, one equation and two unknowns. This thing. And then we have second equation we were looking for. And hopefully we didn't introduce any additional unknowns, okay? But let's see. Let's see what we have right now. So we clearly have two equations right now. And unfortunately, we introduced the third one. Yeah? Do you see that T in the second equation? This is also unknown. So we have three unknowns. So what now? Are we gonna stop here? So yesterday, when I was solving those problems, I spent like basically half an hour on figuring out what the heck is going on in here. Where is the third equation? Okay, so we need third equation, yeah? It took me half an hour to figure out where is the third equation. Any ideas? Yeah. I'm gonna give you a hint, guys. And the hint is so obvious that I missed it. Yeah. Any ideas how to find? Yeah. Also, the thing is here. Wait a second. Oh. This is the hint that they gave us. Oh, come on. Yeah, they ask us to find AB relative. Yeah. ABA relative. Yeah. 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 They maybe move. Yeah. But you are on the right track. I figure out that the biggest hint is of course here. Yeah. Because so far we just concentrated on each body separately. Now let's concentrate on relative motion. Yes. And that brought me to find the third equation actually. Yeah. So you see, it's like basically, I don't know, font size of, I don't know, 100. and it took me half an hour to figure out how to solve that problem. Yeah, yeah. So anyway, what I'm getting at is that this part is quite abstract. Okay, so be concentrated, and in order to find third equation, we must look at the relative motion of these two bodies. Okay, so let's do that. Yeah. Okay. So relative motion. Relative motion. I think I'm going to steal my drawing. Okay. So relative motion. Let's. In other words, let's look at A, B, A. Yeah. This vector. Yeah. And I wanna steal this drawing. And again, sorry for people who do pen and paper. Oh, come on. Okay, I'm gonna simplify the drawing, okay? Because we don't need many things. We don't need that. We don't need that. We don't need, no, this one we need actually. Yeah. Need this, that guy can, oh, he can stay actually. Yeah. Okay, and I'm gonna give him his head back. Okay, so yeah, so the question I asked myself yesterday was following. So I want to find this thing, okay? And I'm going to ask you guys pretty abstract question, okay? So when you are that blue guy here, if you sit on the trolley and you look at the crate, what trajectory you will see? What relative trajectory you will see? Okay, so if you sit on the trolley and you travel up the incline and you just look at the crate, yeah, what trajectory will the crate have for you, for that observer? Think about it. You can say it out loud. Yeah. Relative trajectory will crate have, yeah? Yeah. I'm not talking about you standing here and looking at the crate, yeah? Because if you stand here, so trajectory of the trolley for this guy is this, yeah? This is the trajectory, this is that line, yeah? And crate will have probably something, trajectory like that. I know. Yeah? For this guy. That would be more, sorry, my drawing is terrible, yes, but that would be like some crazy trajectory for this observer. Yeah. However, for the blue observer, trajectory of B will be much simpler, which is, I don't know, huh?
Like a circle.
Like a circle, yeah. And forget about like a, it will be circular, exactly. It will be exactly the circle, yes. Like a circle, exactly. What is like a circle? I don't know that shape. Okay, so this is our trajectory. It's a circle. At this time, by the way, only at this time instant? Yeah, at this time instant, okay. This is relative trajectory. Circle. And excuse me, sir, but I don't know your name as well.
Caleb.
Caleb. Okay, thank you. Yeah, it's a circle. Any questions? Yeah, and nice thinking, by the way. Nice abstract thinking. Yeah. Okay, so what I wanna do next? So let's introduce our UT and UN coordinate system. Okay, we learned during last discussion. Okay, not last discussion, last week on Friday. So I would like to introduce here UN rel, by the way, relative, and UT relative. Okay. So our AB, so our B in this coordinate system has these components. AN relative and AT relative. Okay? So our ABA relative is dV relative dt, UT relative, plus V relative squared rho UN relative. By the way, system starts from rest or not? They told us it starts from rest. What is this value? That means every velocity is 0. So what is this value? 0. Yeah, system starts from rest. So that means that our ABA relative can be simplified tremendously. We have just, let's say, AT rel, UT rel. Okay, we know that for sure. We know that for sure I can erase that. We don't have that. We know that if in our relative motion, our AB has only this component. Do you see that, guys? That's the whole point of our thing. Yeah, the whole point is to observe that this is 0. The whole point is to observe that this is 0. Okay, so let me write down this expression. You learned, I believe, on Tuesday on the lecture. In the lecture, AB is AA plus ABA, relative, let's say. Okay, so do we know what AA is? Yes, we know. This is AA. So our AA is A star in P direction. Yeah? Now, our AB, we found at the very, very beginning. Can I scroll up the board? I hope you guys don't mind. Check this out. Here. Yeah? We know that it has only horizontal component based on our FBD. What I'm doing today? We know that it has only horizontal component. And ABA we just found here. Okay, let's plug these 3 guys in here. So we will have AYJ plus equal to A star P plus AT rel or ABA UT rel. Okay, so we have 3 different coordinate systems in here, yes? we have J, we have P, and we have UT-rel. We cannot sum vectors like that. We must brought everything to one coordinate system, okay? And I propose that we bring everything to I and J. Let's bring everything to I and J. So this thing is already in I and J. I believe that vector P, this is P, and this is 25 degrees. They told us that in the problem statement. So P will have such components. It will have cosine 25 degrees and sine 25 degrees. Okay, so our P is cosine 25i plus sine 25j. And UT, and now UT-rel is here. So it is negative I. Do you see it? It's negative I. It points in the opposite direction than I. This is negative I, minus I. Okay, let's bring everything here. And we have 3 more minutes. I think I am able to finish that in 3 minutes, guys, okay? So AYJ. Oh, shoot, you're right. Okay, thank you for today. I will finish that problem afterwards. And sorry, I thought we are here till 10:50. Have a nice weekend, guys.